Right.
And then you would just draw this one in the Y.
Mhm.
That's what it means, just draw it on the diagram.
Right, but I wasn't understanding how to draw it on the diagram.
But you found them.
Yeah.
You just draw it like this. This is the chain.
But for the baseball bat, the degree is 105. It's not like. So I wasn't sure like where to put the X.
Anytime you get the, here's the resultant, here's the baseball bat, I guess, or whatever, there's the resultant, you just draw in the X and the Y. So the X goes here, you draw F of X, the Y goes here.
Oh, okay. Thank you. I don't know. My brain
I'm
wasn't.
just overthinking.
Yeah, probably.
So go ahead and get that out and check with each other, or did you guys already do that?
We kind of ish.
How was your
It was good. There were like 25 people in there, so 80. They only took like 15 people and they had like 5 or 6 auditions. So it's a long shot, but we'll see what happens.
But you felt
I
good
got
about it?
Yeah.
You felt good about it afterwards?
Yeah.
So you can be confident that you did your best.
Yeah, and then
Yeah,
whatever
that makes
happens.
sense.
When will you find out?
I think around April, so I have to wait like a month.
How many more?
I have one more audition. Yeah, so not
There's
too long.
others?
Yeah.
What?
There's another.
No, I'm done auditioning, but IU like has one more audition until they let people know.
okay.
Although I don't look at.
Have you heard? When did you hear from Arizona?
They called me and I could minor in the ballet, but I can't major because they do jazz and modern. So they want me to like go out there and re-audition, but I'm not gonna do that.
I'm just not thinking right now because we have time change.
Not an excuse for that. Well, I'm just not thinking it's time to.
Wait.
I was looking at things.
Whoa!
backwards.
Did you just like keep your like bottle in the car or something?
No, I filled it up and put it in the freezer.
Oh, okay.
Because I can't put ice in it because it's too
Yeah.
narrow at the top.
They make little, okay, so on Facebook, they have like this, I don't know what it's called, it's like, I liked this page, and they posted a picture of like these ice cube trays that like fit in like water
I do have
bottles
some
like
of
that.
those actually
Yeah,
too. Yes, those are nice, but this works.
it works.
Okay, any questions about this? No? Alright, then,
Oh, I wanted to ask about the greatest magnitude, what are they asking for?
was that number
8.
9? 8?
Mhm.
8, which, like, would the X component, or the west or the east basically,
Mhm.
be greater, or would the north-south be greater? So like on the first picture, it goes more, it's more towards the west than it is to the north.
Mhm.
So the greatest magnitude is west.
Oh, okay, I got
And if you picture the X and the Y components of that like triangle,
you. Mhm.
the X one would be longer also. But it's basically whichever one it's closest to.
Okay, thank you. Thanks, Walter.
Can you explain number 9?
Yes. Which component would increase if theta is moving towards 90 degrees? If theta is gradually increased to 90 degrees. I'm trying to decide if 90 degrees means like
Yeah, I did.
north or if it means,
To the
how'd you guys read that? The
That's
answers I have are west, west, south,
For what one?
so I'm not sure, it depends on how you read it. Number 9?
Oh, I have north, south, and east.
Me too.
I think that's what I was going to put. I don't know.
I'm guessing that it depends on how you interpret what they're asking, so let's think about this. Yeah, I guess they must mean it's increasing to 90 degrees in from whatever quadrant it's at, because it says it's increasing, so like, for the first picture, which I think that's a little bit confusing, direction wise. For the first picture, if it's starting here, that means they're asking what will happen if it increases towards, basically, in my opinion, that would be 180 degrees. But if this theta is getting to be closer to 90 degrees, I guess. And so if that's the case, if this angle is going more this way, which component would be increasing? And it would be the west component. Because if it's moving this way, it's getting closer and closer west. And the x component, which is headed to the west, would get bigger.
So for the second one, it would be what?
Yes, the second one would also be west.
Third one would be south.
Yes.
Cool.
Does that make sense?
Mm-hmm.
Other questions? Okay. This has been just like randomly shutting off all morning, so tell me if it does. But I'm just gonna rewrite those, that's it until we get to the examples. Some of it's review. Okay, so we've been talking about equilibrium a little bit the past couple days. So that's when all of the forces that act upon the object are balanced, and so this pertains to Newton's first law. When that's the case, then that force is zero, the acceleration is also zero, and it could be doing one or two things. It could be at rest and staying at rest, the first part of Newton's first law, or it could be in motion and continuing in motion. And if it's at rest and staying at rest, that's a special type of equilibrium that we call static equilibrium, and that's the type that we're going to be talking about today. So if it's at static equilibrium, we can assume that it's at rest and staying at rest. But we know that there's the other kind of equilibrium, which I'm not sure has a specific name, but it could also be in motion and staying in motion. But the ones that we're gonna be talking about today will all be at rest, staying at rest. Static comes from the word stationary, stationary meaning being in one place. Thank you. I don't know why it's doing that, and it's really getting me. I'm sure for you as much as it is for me.
There we
Okay,
go.
so. You might get by with just drawing this picture. Where is everybody at? Who gets that? Instead of writing all the words down, but it's up to you. A symmetrically hung picture is suspended by two wires in a rest position. The tension in both of the wires is 52 newtons, and each wire makes an angle of 30 degrees with the horizontal. Determine the weight and the mass of the picture.
Like F net equals F prime.
You're on the right track, yes.
Okay.
Okay, so what do I know about this picture? Well, that's true. I'm not sure if that's gonna help us solve the problem, but
It's kind of symmetrical and it's 30 degrees with 50
it is hung symmetrically, yes. And we know that, what else? As far as what the notes that you just wrote down, it is at rest, and so it has a static equilibrium. So that means that all of the forces are balanced, right? And what are all of the forces drawn on this picture? Or is there another force that we don't have?
Gravity.
Gravity, right. So there's these two tension forces going up, and we also have gravity that's going down, right? And so we know that the y components of the tension force, so each of these have an x component and a y component, right, of the tension. Those two y components of the tension force are balancing out the gravity. Well, what about the x components? What do we know about those? Of the tension force.
30.
They're equal, so they balance each other out. So it's symmetrically hung, so we don't really care about the x components because they are going to balance each other out. And so what we need to know is the weight and the mass. Well, do you guys remember, I don't think we've written this down recently, but it's been a while. The same weight is the same thing as what? Gravity. Weight is the same thing as the force of gravity, right? Because our weight would change if we went to the moon. What would not change?
Mass.
Our mass. Right. So weight is the same thing as gravity, which equals mass times the force of gravity. or I should say the acceleration of gravity. That's confusing. But G is the acceleration of gravity, which is 9.8, okay? So our weight is the same thing as the force of gravity, which is the same thing as mass times the acceleration of gravity. And we could rearrange that in any way we want, but we're also gonna have to find the mass, and so the mass would equal the weight divided by gravity. That's the same formula, just written, solved for mass instead of solved for weight. Okay, so how are we gonna find the force of gravity?
It's just like,
That is gonna be,
oh,
let's try to be really clear, that's the acceleration of
Right.
gravity. I did just say force, and so that's my fault. So that's the acceleration of gravity is 9.8. How are we gonna find the weight, or this right here, force of gravity on the picture? Lauren?
Do you have to find the Fy's and then it balances out with that?
Yes, right, so how am I gonna find the Fy's? Okay, good, so the sine of 30 equals Fy over 52. So Fy will equal 52 times the sine of 30. Which is, okay, 26 newtons. And there are two of those, right? So the total force that's going up is gonna be 2 times 26, which would be 52. And so the gravity then is going, or the weight is going to be 52 newtons. Because they balance. So the weight is 52 newtons, and how are we going to find the mass?
Plug in the weight for the F gravity. Plug in the weight to the top equation to find.
Right, or you could use this one that's already solved for mass.
Okay.
So, but either way, you'll get the same answer. So the mass is the weight divided by 9.8, and so the mass is 5.3 kilograms. Questions? No? Okay. Here's another one. With slightly different information that's given. A sign is hung symmetrically by 2 wires in the physics classroom. The sign has a mass of 2.8 kilograms. And the wires make a 38-degree angle with the horizontal. Determine the tension in the wires. So this time we've been given the mass and we need to find the tension. So here's the sign, and it has a mass of 2.8 kilograms. And wires, again, that make a 38-degree angle. And so we have to find the tension. So what should we do first?
We could plug the mass in to find the gravity.
Good. Good, so we know that gravity is the force of gravity, which would be this, we don't have that labeled. The force of gravity is mass times the acceleration of gravity. And so that will be 2.8 times 9.8, which gives you, okay? Good. And so that tells us what?
The y is set to be 13.72.
Okay, good. So that means that each of these y forces on the wires have to balance with that. So each of them would be half of the gravity, which would be 13.72. Okay, so when we know that, we can look at this triangle where we have the tension force, the 38 degrees, and the F of y. And how are we going to find the tension then?
If we find f of x, we can use Pythagoras.
You could, or you can use trig. I mean, that is trig also, but we have this angle, right? So we could do the sine of 38 equals 13.72 over the tension force. Right? That's not how it's normally set up, but we can still solve that. So we have the tension force times the sine of 38 equals 13.72. And so how will I solve that to find the tension?
(13.72) divided by sine.
Yes, divided by the sine of 38. Which will equal
22.28.
good. So let's just round that to the nearest Newton, and we'll call that 22 newtons. Questions about that?
I think I did something wrong because when I did the Pythagoras way, I got 17.
Well, how did you calculate the x component?
The cosine of 38.
That's the problem. Because you don't know
So I
the
don't know it.
hypotenuse.
Okay, that makes sense. Thank you.
So I don't really think that's a good way of doing it.
Don't do it that way.
Because you'd have to use tangent to find that one, and then you'd still have to do one more step after that, so.
Okay.
Okay, just one last note. Go away. Just one last note about this, which kind of goes along with what we were talking about with your question at the beginning of class. As the angle with the horizontal increases, we're talking about the wires to hang pictures specifically, the amount of tension force that's required to hold the object will decrease. For number 4, it doesn't tell you this, so without measuring with the ruler, you wouldn't know, but number 4 is at equilibrium. So you can assume that the object in number 4 is at a static equilibrium.